as you all remember, functions deals with what? The fx and gx. Like last week, you saw a lot of fx, you saw gx, and I believe I mentioned that fx and gx is the same exact thing, well, for CXC purposes, as the letter y, right? So anytime you see fx, you can also throw it away and replace it with the letter y. And wherever you see gx, you can throw it away and, of course, replace it with the letter y, right? So, all right, just to clear up quick issues. Now, when it comes to functions, right? Well, not only functions, almost any part of maths, you have two options. One, you can do calculations. And I think up to this point in time, we did a lot of calculations. Or some people don't actually like to do calculations. Instead, when they do maths, they like to do drawings. Because drawings, some people are just better at picking up information from a drawing rather than looking at calculations, right? And the drawings that we're going to encounter today is going to be graphs, okay? I myself, I'm a picture person. I learn faster from seeing a picture or a photograph. If somebody writes a whole set of stuff for me, it gets jumbled in my head. And today we're going to explore that. So we're going to explore two special types of functions. So keep in mind, there are hundreds and thousands of different types of functions out there. Whenever you hear the word linear, I want you to think of a straight line. So that's a general word you're going to hear, not only in maths, but somewhere else, right? It could be social studies, it could be, it could be history. The point is, the word linear, always think of a straight line. In other words, whenever you hear the word a linear function and you have a graph, and a graph has an x-axis and a y-axis, whenever you draw that particular function, you will get a straight line. You will not get a curve. Now, straight lines can slope upwards, or it can slope how? Downwards, but we'll get to that in a little while. The other types of functions that we're going to bounce up in about 2 weeks is something called a quadratic functions. Now, a quadratic, when you draw it on graph paper, it's a special type of curve you will get. In maths, there are lots of different types of curves. Let me just draw a few here that are not on the syllabus. Sometimes you have a curve going up and down. Sometimes you have curves like this. A circle, believe it or not, a circle is a type of curve. And for those who plan to do Form 6, you're probably going to see a curve like this whenever you're doing Form 6 maths. And you draw it on your graph paper. It's a up and down, and the up and down gradually gets smaller and smaller and smaller. I could continue and draw and keep holding and just drawing different types of curves. But quadratics, whenever you draw a quadratic function, you will only get one of the two shapes. Either you're going to get a kind of, what I call this a smiley face, or you will get a rainbow. But some people call this a smiley face, and some people call this a vex face or a frowny face. All right? But we won't be meeting up quadratics till about 2 weeks from now. All right, so for the time being, today's main topic is linear functions. Just take down linear functions and just make a mental note. Hey, linear functions, when you draw it on graph paper, we must get a straight line. Right, so take a 10 seconds and we will be moving on. Nothing too much to take there. That's linear programming. All right, so here's what I need for everyone to do. Remember, I'm suggesting you do not use graph paper. Everyone just draw up your y and x axis. Just quickly make your x axis go up to +8, your y-axis to +8, down to -2, and backwards to -3. Now, I'm going to be building on what we did over the summer. For those of you here over the summer, we did a lot of graphs work. All I require you all today to know is how to plot a point on a graph, like how to plot the X and Y coordinate. And once you can do that, everything is going to be easy today. For those who might be a little rusty on doing that, don't worry, I have a plan. While I'm plotting the first few points, I will slow down a little bit initially so you can try to pick up on it. Right, so let me know when you're finished taking down, drawing a little makeshift graph in your notebooks. All right, so on the screen, we have our very first function to draw. The function is fx is equal to 2x plus 3. Now, usually it's very, very easy to spot a linear function. Linear functions only have simple things like y and x. Remember, fx is the same exact thing as y. So if you look at the equation, you don't see anything really fancy in it. It's just x and y, right? But the minute you start to see fancy things like x squared and the square root of x, or y squared, or even x to the power 3, when you draw these types of equations, anything involving something really fancy, you will not get a straight line. Instead, you will get a curve. But we are not focusing on curves right now, okay? So whenever you have to draw a straight line, your teacher will tell you that you need 3 points. Now, the truth is, you could draw a straight line with only 2 points, but teachers will suggest 3 points because if you do calculations for 3 points, you're less likely to make an error. That's the only reason your teacher will tell you to use 3 points. And CSEC kind of agrees with most teachers that you should do 3 points to draw a straight line. So let's do some calculations. Whenever we're drawing graphs, right, we need x values and we need y values. Once again, I'm going to keep saying it over and over. Y and fx is the same exact thing for CSEC purposes. If it's a straight line, right, you will be in charge in most cases of choosing the x values. Now, let me explain how to choose the x values. When you have your graph, right, you notice my graph goes from where? -3 all the way to +8. So in the exam, you see how I filled out the -1, the 1 and 2? Most likely the examiner is not going to do that. It will be up to you to choose 3 values. So I know what you all are thinking already. If it's up to the student to choose these x values, won't everybody in the Caribbean who is writing the exam, won't almost everybody choose 3 different values? Like instead of choosing -1, somebody in our next school might choose 3, and then somebody might choose what? 9. Who's to stop the student from choosing whatever values they feel like? But here's the good thing. It's like magic. It doesn't matter which 3 values you choose for x. When you draw the graph, if once your calculations are correct, guess what? Everyone will get the same graph. It will look exactly the same. But you gotta be a little smart when you're choosing your x values. If my x-axis that's in front of me starts at -3 and ends at 8, do you think it makes sense to choose 9? Well, what do you all think? Do you think it's a good idea to choose 9? Tell me your thoughts on that. The answer will simply be what? No, because if I choose 9, it's not going to fit on my particular graph paper today. And of course, if I choose -4, that won't make any sense. It won't fit on my graph paper. In other words, I have to be smart and choose something between -3 and +8, which I did. I chose -1, +1, and +2. That will ensure it will fit on my x-axis. So once we choose 3 good values for x, guess what we have to do now? We have to calculate the corresponding y values. So to calculate this y value, we have to go to the equation, right? Remember, the equation is fx is equal to what? 2x plus 3. Over here, we are pretending x is what? -1. So guess what we're really doing? We're trying to find f -1. You all remember what f -1 means? It means you're going to the function, and wherever you see the letter x, you throw it away and replace it with how much? -1. And you work this out and you'll get the corresponding value here. Do you all think you all can work that out for me? What's the corresponding value for y when we are pretending x is -1? In other words, we are finding f -1, right? Daria, correct. Right, so Jordan, you have all already. Right, I think we're going to get +1. And some people said -1. Look at it. And I just being fair, right? I'm not going to be focusing on working out values, because by now, everyone should be real comfortable with positive and negative numbers, okay? So 2 multiplied by -1 is -2. -2 plus 3 is +1. So now we have to figure out this value of x, which means we are pretending x is now what? +1. So we are trying to find f1. So 2, replace the x that would be here with 1. How much would be the corresponding y value? Right, you will get 5. 2 by 1 is 2 plus 3 is 5. And do you all think you could do the last one for me? But you see how I put in the work in for the examiner, right? You all notice how I put in it, right? F2, which means we are pretending x is 2, so we can work out the value to find y, right? 2 by 2 plus 3. I think we will get what? 7, okay? So now we have 3 points to draw on the graph paper. In case you can't remember, a point has an x coordinate and a y coordinate. The x is the horizontal value, the y is the vertical value. The first point is -1, 1. So look at it. We go on -1 on the x-axis, and then we go up to +1. That's my first point there. -1, 1. That's this guy here. The next point is 1, 5. The x-coordinate is +1. The y-coordinate is +5. So we go to +1, and then we go up to +5. Look at it. It's hovering over +1 and in line with the 5 on the y-axis. And the last point is 2, what? 7. 2. And we go up to where? 7. And we have the 3 points. And look at those 3 points. If we were to connect them up, now I don't have a ruler here, right? We will get what kind of line? A straight line, okay? Everyone draw it in for me as well, as neat as you could on your makeshift graph, right? Or, I just let you know, in the exam, whenever you draw a graph for the examiner, you have to label all the points. Like you see how this point was -1, 1, you put the x coordinate and then the y. And this point is how much? 1, 5, you put a comma in between them, and this point is 2, 7. 2, 7, x, y, the x before the y, right? To get full marks. Right. Don't worry, Cameron. We only have to do this topic for the next 4 weeks. All right. Now here's the thing, right? Whenever we're drawing straight lines, and this only applies to straight lines, not curves. If you have your X and Y axis, you see how I connected all 3 points? When I connected all 3 points, it looks something like this, right? What you're really supposed to do is take your ruler and continue the pattern. You're really supposed to go to the end of the graph paper on both sides. So to get full marks in the exam, you're really supposed to go down like this and go up like that. So for straight lines, you just have to take your long ruler and complete the line. The 3 points you plotted only serves as a guideline to how the rest of the graph should look. So remember this, always extend it to both ends of the graph paper. So make sure and do it in a makeshift drawing there, right? Just don't say, when the time comes, I'll do it. Do it now, and let's get into the habit of doing it. Let me know when you guys are finished. Right, so I think on the next slide, I have a proper drawing of it. So let's take a look at it. Right. Did it look something like this on your paper, on your end? Well, when you extended it, did it land in between the -1 and the -2? Right? This is how much, like I said, I use a computer to draw this one. Right? So, right. So let's talk a little bit about the equation of a straight line now, right? Human beings like to describe things. If you ask anybody about something, whether you ask them to or not, they will most likely describe it. Like a car. If you ask someone, hey, what kind of car you saw? You could say it's a red car, it had 4 wheels, it had I don't know, headlights, whatever, right? The point is, we're good at describing things. Let's describe this straight line, okay? So let's have a look at this straight line that we just drew. Pretend it's a mountain slope and you're always walking from left to right. How would you describe that slope to someone? Is it sloping upwards or is it sloping downwards? Pretend you're on the phone with somebody and they can't see the line, right? Right, at even first glance, and without even me telling you, you said, hey, that this line is sloping upwards because you're walking from left to right. That means you're gonna go up the slope of the mountain, right? So next question, right? So I think we all realize that when you're describing a line over the phone, it can either slope upwards or it could slope the opposite way, downwards. But today is upwards. Next question now. If it's a side of a mountain, some mountains are hard to climb and some mountains probably are not too hard to climb. The word I'm looking for to describe it now is steepness. Some mountains or some slopes are very steep, while some slopes are not very steep. In maths, the word for steepness, right? You see this word here underlined, it's in blue. Gradient. Gradient is the same thing as steepness. Now, the thing about maths, we can actually put a value on how steep something is. We can put a value on the gradient. And the larger the value, the steeper it is. For example, let's make up something here. If we have a line that's not too steep, we could say the gradient is probably 2. But if it's much steeper, you notice this is harder to climb up. If we were to do the calculation on this line, we are more likely to get a larger value. The symbol for gradient in maths is the letter M. Don't ask me why most textbooks use M. If it were up to me, I would use the letter G. But most textbooks use the letter M. Not my fault, right? So whenever you're doing linear equations and you see the letter M, that represents the gradient. So Well, what do you all think about this mountain slope? Do you think it has a high gradient? I mean, a large gradient or a small gradient? Pretend it's you trying to walk up that slope. Do you think it will be difficult, or do you think that's going to be easy? Right? Right. To me, that looks difficult, right? By the time you reach the top of that mountain, your legs hurting, right? So most likely, when we attempt to calculate the gradient later on, we're going to get a large value. Now, when I say a large value for gradient, right? Believe it or not, 5 is considered a very large value for gradient. Things like 1 and 2 and 0.5 and fractions are considered small gradients. Okay, so we're going to bounce up that there. So far, we know 2 ways to describe this line. We could tell the person on the phone, hey, it's sloping upwards. And we could also say it not only sloping upwards, it kind of steep. The gradient might be large. How else can we describe this so the person on the other side of the phone can understand? Look at the y-axis. That's the vertical line. You see the red line? Where does it slice the y-axis? At what number? Well, where does it cut the y-axis? Right, look at it, it's slicing the y-axis at 3. That's another way we could describe it to the person on the phone. And where it slices the y-axis, there's a fancy name for that, right? Right? You call that the Y-intercept. To intercept something means to cut it off, right? Right? When the police intercept a vehicle, they're cutting off the part of the vehicle, right? And the letter used to represent the Y-intercept is C. Once again, I didn't choose that letter. It was up to me. I used the letter I. Okay? To me, that would have made more sense. Okay? But let's go with what they have. So here's the thing. Whenever they give you the equation of a line, right? Right? Like this is the same equation we had here. Y is equal to 2x plus 3. But instead of the y, we had fx. Whoever is touching x is your gradient. It's real easy to identify who is the gradient. And whoever is not touching x is the y-intercept. Remember, M is for gradient, C is for y-intercept. However, right, this only works if who is the subject? If y is the subject, which means y needs to be on one side and everyone else needs to be on the other side. And here's the thing. The sign of the gradient can actually tell you whether the line is going upwards or the graph will be going downwards. Anytime your gradient is positive, when you draw it on graph paper, it will slope upwards. And whenever your gradient is negative, the graph will always go downwards. But you notice in today's question, the gradient is positive too. So that's why when we drew the graph, it will be sloping how? Upwards. And you notice your y-intercept is 3. You notice your graph did cut the y-axis at 3. Now, here's the thing, right? I don't know why it is like this in maths, right? When we're describing the equation of a straight line, people are quick to point out the value of M. They're quick to point out the gradient. They're quick to point out where it cuts the y-axis. But how come nowhere in this equation you can look at it and tell where it cuts the x-axis? Look at it. Well, where does it actually cut the x-axis? When we extended the line, didn't it cut the x-axis in between -1 and -2? So that most likely is -1.5. For some reason, right? Not my rules, right? For some reason, it's not too important to tell the person over the phone where it cuts the x-axis. Where it cuts the y-axis takes preference. But I'm just saying, right? If I were to smudge this out by mistake, right? Let me say somebody take white off and they smudge up this whole area here, right? Like that. And you wanted to figure out where it cuts the x-axis. There's a very easy way to figure that out through calculations. So I'm guessing that that's why the examiners don't care for you to directly point out where it cuts the x-axis. There's a calculation you can easily do to figure that out. And of course, I will make sure and show you that. Take down everything on the screen here. Please let me know when you are finished. All right, so what we're going to do now, we're going to actually work backwards, right? Now we know the equation is supposed to be y is equal to 2x plus 3, right? But let's just say that this got scratched off, right? Rain fell and it erased that part of the paper. So we don't know the equation. We don't know the value of the gradient, but we pretended. And we don't know the y-intercept, right? But we know it's a straight line. So here's the thing. The equation of any straight line is supposed to look like this. Y is equal to mx plus c. Remember, we just said whoever touching x is the gradient and whoever is not touching x is the y-intercept. So let's work backwards and see if we could calculate the value of m and calculate the value of c and get back that original equation. So whenever we have to find the equation of a straight line, this is my advice. You always try to find the gradient first. The gradient is the letter m. We have to use this formula, y2 minus y1 divided by x2 minus x1. Take down the formula. I know some of you are probably wondering, but where does y2 come from? Where does y1 come from, right? For those who already know how to do it, you go ahead and do the calculations. You don't have to wait on me, right? Whenever you have to find the gradient of a line, and the examiner was so nice to draw the line for you, all you need to do is choose 2 points on the line. Any 2 points. Once again, since it's up to the students to choose 2 points, everybody in the Caribbean is going to choose 2 different points, but you're going to get the same answer. But I always look for easy points to choose. For example, look at this point here. And he real easy to figure out. Well, what's his value? And his x value is -1 and his y value is 1. So he's an easy point to choose, -1 and 1. Remember, you have to put the x first and then the y. And let's look for another easy value. This one is a hard one because he kind of hard to estimate what the x value is. How about this guy here? You think he's an easy one to choose? Well, what's the value of this point here? Make sure you state the x and then the y. He should be real easy to figure out. What does he look like? Right, he is 2, 7. 2 on the x, 7 on the y, right? So once you get 2 points, choose any one of the points first. It really doesn't matter. So if I choose the lower one first, remember, he has an x value and he also has a y value. Because we are choosing this point first, we assign the letter 1 to him. They call that a subscript. He's x1 and he is what? y1. And the second point, because we're paying attention to him second, you're just going to call him what? x2 and y2. And all we have to do now is throw him in the formula here, right? Sorry to cross the line here, right? According to calculate the gradient is y2 minus y1. Now I want to pay particular attention to this formula. You notice this formula has a minus sign here and a minus sign here. When you buy this formula in the formula store, you get two free minus signs, one on top, one underneath. Please do not ignore them. They're very, very important. Sometimes in maths, two minus signs may touch and you get a positive. Sometimes they do not touch and you get back a negative. Just be on the lookout. That's all I'm saying. So what's the value of y2? Y2 is how much? 7. The formula says I must put a minus sign. I have no choice. And then I have to put y1 after. Where's y1? Hey, look, y1 here. So I'll put them here. Let's go to the underneath now. x2. x2 is 2. The formula says I must put a minus sign after. I have no choice. x1 is how much? But look at x1. x1 has its own minus sign. So be careful when you put it in here. N2 minus sign is going to end up what? Touching? So let's work out the top now. 7 minus 1 is 6. Well, 2 minus signs will touch here. 2 plus 1 is 3. 6 divided by 3 is 2. Wasn't that supposed to be what? The gradient? Remember the gradient? Let's scratch it off here. And the gradient was 2. Look, we got back to 2. So we now know the value of m from calculations is positive 2. So this is what we know so far. Y is equal to, we know m is 2 now. We put back the x. But what is missing? C. We still need to prove C is what? 3. All right? Right. Now, remember, C is the Y-intercept. Isn't the Y-intercept where the graph cuts the Y-axis? So couldn't we just look at the graph and see, hey, it's cutting the Y-axis at 3? And from that, from just looking at the graph, we can throw away C and put what? 3. From just visually looking at the graph. That's one way of finding the Y-intercept. Or you could use this note underneath here. Everyone take down this note. This shows you how to find the value of C without directly looking at the graph to see where it cuts the y-axis. And you're probably wondering, well, if I could just look at the graph, why is it showing me how to calculate it? I'll show you why just now. It's a backup plan. All right. So let's just say that the examiner says, like, for some reason, right, they blank out this piece of the graph. Like the examiner didn't show you this piece of the graph in the exam, right? But he wants you to figure out where it cuts the y-axis. And now, notice now, you can't actually physically see. So you resort to calculations. Now, according to the note, sorry, it says that you could, once you have the value of m, so we have m, that's the first step. Choose any point on the line. Any point. So we already have 2 points. So we could choose the one underneath, or we could choose the one on top. Let me just choose the one on top. According to the point on top, x is 2 and y is 7. So all you have to do now is go to this equation, pretend y is 7, because that's what we're doing. 2 is the what? Gradient. And then pretend the x value is positive 2. So make sure and put it in brackets. And then we have what? Plus c. And all we have to do is transpose to solve for c. 2 by 2 is 4. And everyone can do this in a head by now. When you throw across positive 4, you get minus 4. Look, 7 minus 4 is 3. We got back 3. Take down that working, and then I want to prove to you that if you chose a different point, like we chose the underneath point, I bet we would still get back 3. It doesn't matter which point we choose once the point is living on the line. So take a 20 seconds there. All right, so let me prove to you all now, right, that once you find the value of m, it does not matter which value on the line you choose to find c. So let's go back to the drawing board here, right? Let's choose this point underneath here now, the -1 and 1. Or according to this point, we pretending y is 1. So this time we are replacing y with 1. The gradient is 2. And now we are pretending x is -1. So -1. Let's see if we still get 3. 2 multiplied by -1 is -2. Let's solve for c. Throw across -2. What you get? +2. 2 plus 1 is 3. We still got a 3. It cuts the y-axis at 3. Right? So I know some people mightn't take that one down, but for those who want to take it down, take a 20 seconds. Right. So remember I said, right, whenever we have the equation of a straight line, we can easily look at it and pinpoint the gradient. The gradient is 2. He's touching x. And the item not touching x is the y-intercept, the letter c. But remember, I said, and I promised you all, that there would be a simple way to figure out where it cuts the x-axis. Now, from just looking at this, right, it looks like it's cutting the x-axis at where? -1.5. To get this -1.5 via calculations rather than looking, take down this note here. To find the x-intercept, well, the x-intercept obviously means where it cuts the x-axis instead, right? Replace y, the letter y, well, we're talking about the equation, with 0, and then solve for x. So we're going to try that now. And of course, we're hoping to get something close to -1.5, if not exactly -1.5. Right, so let me write back the equation here. So according to this note here, it says all we need to do is replace the letter y with 0. All right, so let's throw away this y and replace him with 0. And then it told us to do what? Solve for x. So let's solve for x and let's see what happens, right? So when we throw across, that's not what. When we throw across the positive, well, you all solve that for me and tell me if you get -1.5. Right? Justin, check back your working. That's wrong. Check back the working, Justin, right? Remember, when you throw across +3, and we're supposed to get -3, I think too many people forgot to change the sign, right? And now the 2 is a multiply. Throw it across, you get what? A divide. So we get back the -1.5. -3 divided by 2 is, Dana, check back your signs. Remember, -3 divided by 2 is -1.5. Right? So I guess the all right, so it comes down to this now. We're going to try back an entire question, but with a different function this time, right? So let's everyone draw back a fresh makeshift graph and draw it just like this, right? So make sure the y-axis going up to about 7, -1 here, +4 here. Wait on me, right? You draw it, leave a blank diagram, and we doing this one together. Okay. All I did up here was just I throw away the fx and I just replaced it with y to make it a little easier on the eyes. So the examiner has asked us to draw this graph. Now, once again, I know if we draw this, we're going to get a straight line. And recall, right? You know you're going to get a straight line because it only has simple things like y and x, nothing fancy, no x squared and x cubed and whatnot. Quick question, right? How much is the gradient and how much is the y-intercept? Send your answers like this. M is equal to what and C is equal to what, right? M stands for gradient and C stands for your y-intercept. Send it on the chat there. And let's see if you get the signs correct as well. So because y is the subject, it's super easy to pinpoint the value of M and the value of C. M is -3 because whoever is touching X is the gradient, and whoever is not touching the X is their y-intercept. So even before we begin to draw this, will our line slope upwards or will our line slope downwards? Even so, in other words, we're predicting our answer. Right. It's supposed to slope downwards because if you look back in your notes, anytime your gradient is negative, the graph's supposed to slope downwards. So when we finish, the graph's supposed to be going this way. If it's not going downwards, that means we do something wrong. Also, our y-intercept is supposed to be +6. So it's not only sloping downwards, it's supposed to slice the y-axis at 6. So it's supposed to slice right here. So if we draw this graph and we're not seeing those two conditions being fulfilled, we need to check back our working, okay? So let's choose our values for X now. It's a straight line, so we need to choose 3 values for X. This is where I said everybody in the Caribbean is going to choose 3 different values. I don't want us to have different values. So let's just agree on some values. I'm going to choose, and I'm just choosing for you. I have to choose, I'm going to choose -3, +2, and 5. What do you all think about my values? Good values or bad values? Somebody said good values, right? Yeah, Jordan, that could work. These are horrible values. There's only one of my values here makes sense. Look at my x-axis. It's the smallest value I have is -1 and the largest one is 4. I have to choose things that could fit on my x-axis. -3 is quite down here. That can't fit. And 5 is kind of after this, but it still can't fit, right? Only 2 could fit. So I think those are horrible values. So how about -1, 2, and 3? How that looking? Right, these looking okay to start off with. All right, so let's now sometimes you start off with 3 values, and the 3 values at first seem like a good idea. And in most cases, they will be a good idea. But when you do the calculations, you might run into some problems. If you run into problems, don't break down and cry, right? Just choose a different value and hopefully things will what? Work out, okay? So let's start off with this one. Let's find f -1. That's this here. Go to the equation and replace x with -1. Throw away this x, replace it with -1 + 6. What will we get there? Right? We should be real familiar with how you say evaluating functions by now. Throw away x, replace it with a value, work it out. I think we will get 9. right? Minus 3 by minus 1 is positive 3. And add it to 6, you get 9. Right? Let's do the calculations first, and we'll see what problems we run into after. So 9 goes over here. You think you all could find F2 for me? Go to the same equation and replace X with 2. Right, Jaden, correct. Right. Right, Tamara, correct. Jeremiah, correct. Chanel, correct. Michael, Shifter. Caitlin, check it back. Minus 3 multiplied by 2 is minus 6. Minus 6 plus 6 is 0. We're getting 0 here. Make sure you see it. Make sure you see it on the calculator. Right, Mohini, you have some answers there. Right, so let's try the last one there. F3 minus 3 by 3 plus 6. I'm getting minus 3. All right, so let's look at the problems now. All right. Look at this first value and look at the graph the examiner gave you. The examiner will give you the graph in the examiner. He will have the X and Y axis labeled for you already. So you can't come and change it. The first point is how much? Minus 1, 9. Minus 1 is a good value. It could fit on my x-axis, but then I have to go up to where? Positive 9. We run out of luck. Our y-axis only goes up to where? 7. So we have to do some readjusting here. We can't use minus 1 only because it gave us a bad y value. Can the second one fit? 2, 0. 2 on the x and 0 on the y. So that means you're not going up and you're not going down. It's right on the x-axis. That's the point. 2, 0. Can the next one fit? So he good. How about positive 3? But then we have to go down to where? Minus 3. Oh, that falls off my computer screen. That one cannot fit either. So, and this happens all the time in the exam, right? You start off with good X values, you jump for joy in your head, you say, yes, it's gonna work out. And then when you complete the calculations, it doesn't fit. Right, so it's a little bit of trial and error. So we needed to try back these two here. So the minus 1 and 0, and this, we have to recalculate. This is one of the best values to choose for X whenever you're having problems. Choose X as 0. You think you want to do back that one for me now? Choose X as 0. So we find an F0 and tell me what you get for the Y value. Right, so people are getting, right, the same answer I'm getting in my head. I am getting 6. Minus 3 by 0 is 0. Anything by 0 is 0. Plus 6 is 6. Can this one fit now? 0. And then we go up to where? This one could fit here. So plotted 1 times 0, 6 is up here. And well, so he good now, he good. I think our only choice here now is to hope and pray that 1 works. You think 1 will work? I think 1 working, yeah, 1 working. You're getting positive 3, you're getting positive 3. We got all of them to fit. Yes. 1, 3. 1 on the X, 3 on the Y. And look at that, guys. If you take your ruler and join this up, well, you'll do a better job than me and go to the end of the graph paper. You notice the graph did slope downwards as predicted, and it did slice the y-axis at exactly 6. So you can walk out that exam room now feeling what? Confident, right? So here's 0, 6, 1, 3, and 2, 0, right? It's so nice in maths when you can predict the answer, and when you finally work it out, you actually get the answer, right? That doesn't happen all the time. Right, so this is a neater version of what I'm supposed to have, right? So here's what I need for you all to do, right? As a small exercise, we know the gradient is supposed to be what? -3, and the y-intercept is 6. I want you all to verify via calculations that the gradient is -3, and by calculations that the gradient is 6 using this graph. Remember, it's up to you to choose 2 points on the graph to calculate the gradient, but choose 2 easy points. Like, for example, this is an easy point. This is an easy point. This is an easy point. It's very easy to figure out or estimate the x and y values, right? Do not choose points like this, because you know the y value is 5, but you ain't too sure what that x value is. That's a horrible choice. Get started and let me know when you're finished verifying. So let's work out the gradient. I'm going to choose the underneath point here first. So I'll call it x1 and y1, right? And the other point on top will be what? x2 and y2. Doesn't matter which one you choose first. So according to this, y2 minus y1, 6 minus 3, that is on top. And then x2 minus x1. x2 is 0 minus, and x1 is 1, right? So 6 minus 3 is +3, but 0 minus 1 is -1. So 3 divided by -1 is -3, right? So you gotta be careful about the signs, huh? Right? So for those who got +3, let's just check back your work. It's a real small error you're making. So this is what we know so far. The equation of any straight line is y is equal to mx plus c. It's always going to be in that format. And we just calculated the gradient is what? -3. We just have to find c, or your y-intercept. To find the y-intercept, you choose any one point on the line. I'm going to choose the middle point here. According to this middle point, we have to pretend y is 3 and x is 1. So pretend your y is 3 and your x is 1. 3 is equal to -3 plus c. Solve for c. Throw across a negative, you get a positive. Look, we got back the 6. And we could see that it slices the y-axis at 6. So we know your y-intercept by calculation is also 6. Do you all think you all can calculate and find the x-intercept? Remember, the x-intercept is where it cuts the x-axis. That's the one where you have to pretend the y or fx is 0 and solve for x. See if you get back the 2 for the x-intercept by pretending y is 0. Right, and verify when you get it. So we know the equation is supposed to be y is equal to -3x plus 6. To figure out where it cuts the x-axis, we suppose to pretend y is 0. So that's exactly what I'm going to do. I'm going to throw away that y and replace it with 0. And let's solve for x. throw across positive 6, we get minus 6. The minus 3 is a multiply. When you throw across a multiply, you get a divide. Look, we're getting positive 2. Right? So if you get a negative 2, just check back your signs, all right? So we did this question already. I just rushed it a little bit. All right. So here we have another function, right? So you'll notice the graph looks a little bit different, right? We should be able to finish this one question here today. Everyone draw this strange looking axis. You notice the y going up to positive 2, but it's going down to negative 6 now. Okay. Draw the graph. Wait on me. We're working this one out together. So, well, for this equation, I didn't bother to put the fx, right? I straight out use the y. Can we look at this equation that we are supposed to draw? Can we, just by looking at it as how it is, can we identify the gradient and y-intercept? What do you all think? Do you think it's possible by just looking at that? Right, Khadija, correct, right? The answer to that question would be no, right? Because I know it have simple things like y and x. So I am sure that if we draw it, we're going to get a straight line. But the equation, the preferred version of a straight line is y is equal to mx plus what? C. Whoever is touching x is your gradient, and whoever is not touching x is regarded as your y-intercept. But that only holds if y is the subject. Look at this equation. I purposely tried to trick you. You notice y is not the subject. So could you all use your transposing skills to make y the subject and make sure the x's are separate from the non-x's? And only then, only at that point, you can make the decision of who is gradient and who is y-intercept. No other way, right? So take a few seconds and make y the subject. Let me see. To make y the subject, I think we have to throw across the positive 10 first. So you throw across positive 10, you get minus 10. And then this 2. Now, the problem is you can't squish the 2x and the 10 together because one have an x and one doesn't. So this 2, which is a multiply, when you throw him across, you will get a divide. But you have 2 items waiting here. So you have to divide both of them at the same point in time by this 2. So now we get y is equal to 1x, well, positive 1x minus what? 5. Now we can identify who is the gradient and who is the y-intercept, right? I would prefer if you put the 1 here. I know if you don't put the 1 is understood, but today put it in, right? So this is your gradient and this is your y-intercept, right? Your gradient is 1 and your y-intercept is minus 5. Quick question. Would the line slope upwards or downwards? Right, it's supposed to slope upwards because 1 is really positive 1. It's just I didn't bother to put the positive sign. So it's supposed to slope upwards. So when we draw this graph today, it have to be sloping upwards. And it's supposed to cut the y-axis, that's this guy here, at minus 5. So it's supposed to slice over here. That is minus 5 there. 0, -1, -2, -3. It's supposed to slope upwards and slice at -5. So when we're doing the working today, let's see if we end up with that scenario. Okay. So we have to choose 3 values for x again. Now, I think you all know the tricks. I have to choose something in between -1 and 5. So let me quickly choose something here. I'm going to choose 0 today. 1 and 3. So calculate the corresponding values for y now. You got to use this equation. Eh? Remember, y and fx is the same thing, right? So replace x with 0, then replace them with 1, then replace them with 3. Caitlin, check it back, right? All right, so for the 0, remember, if you're pretending x is 0, 1 by 0 is 0, right? -5 is -5. If you replace it with 1, 1 multiplied by 1 is 1, -5 is -4. And then if I choose the 3, now, Kenya, check back the last value. If you replace here with 3, that's the last value. 1 by 3 is 3. 3 -5 is -2. The last one is supposed to be -2. So check it back, guys, right? Right? Right. Right. So for those who want, well, let me skip. So for those who want to plot the points, plot the point. All right. So they plot these points and see what we come up with. The first one is 0 -5. 0, and we're going down to -5. Next point is 1 -4. 1, we're going down to -4. And the last one is 3 -2. 3. Hey, looks like we got a straight line, right? And it matched our prediction. It's sloping how? Upwards, and it's slicing the y-axis at exactly -5. Right? So let me know when you get that on your end, like it matched the prediction. So the homework is officially to go to the maths classroom, and we are looking for lesson 12. Make a note, lesson 12, that's quadratics, but I don't want you to do the whole of quadratics as yet. It's just one video inside lesson 12. So when you go into lesson 12 and you scroll down, I just need you to do video 23. That's all I need you to do, right? Video 23. Try to have it ready for next week, right? Like I said, it's not a long video. So inside lesson 12, video 23. Right. And for those who have to sign up for the CSEC exam, I have a big button here on the menu. It's called CSEC May, June. Registration is on. Just click on that. And when you scroll along, it have the link here. CSEC 2023 June link. As simple as that. Click on it, fill out the form. It have other options to see all the instructions and everything. Just play around with it, and it should be smooth enough. All right, guys, so you're free to leave, okay? All right. Have a good night. All right, Caitlin.